All right, AP Precalculus students, let me get to the right spot. We are on our video lesson for week 2, and this week we started with our content, so I always try to have some jokes at the beginning. So let's see, you really should brush more. You've got a huge concavity, right? So hopefully you remember seeing the word concavity this week. We're going to spend some time reviewing key terms from this week. Well, if I wind up needing a root canal, at least both my roots are imaginary, right? It's not touching the graph. Very fun. All right, so here we have also well-behaved functions, right? Because each input goes to a different output and we don't have any repeats. And a poorly behaved function, remember, this happens constantly, right? Because this is all inputs. No matter what we choose for x, we get the same y. So it's a straight line, and this would be not a function, right? So it's always giving us, it's a horizontal line. No matter what we pick for x, we get out of the same y. So remember, we talked this week that all relations are all functions are relations, but not all relations are functions. So it's kind of some jokes. So what are we going to cover in today's video lesson? We're going to do some basic housekeeping. So I want to make sure that you're submitting the lessons correctly. There was a couple questions that I always get from this week, so I was going to go over those with you. On the late policy, I just want you to make sure you understand that I put an assignment every day on Moodle. So there's an assignment for Monday, Tuesday, Wednesday, Thursday. This is always, the video lesson is always the Friday assignment. If you don't do them on that day, that's all right. You just need to make sure you get all the lessons done by Sunday. The 5% reduction cannot apply to the SCORM packages, right? These on the course page, these are SCORM. Each of these where you see the points, those are SCORM lessons, and there's no reduction on these if they're late, because then I can't have it set to the points. So you need to get 18 to 20 points on this lesson to unlock this lesson, and so if I put a reduction for late work, you won't get into the next lesson. But let's just work within the week and we won't have that issue. But just know that, even though it's showing you what to do each day, right? Monday is the introduction lesson. It's showing you what to do each day. If you don't get that done each day, then it's okay. Just get it all done by Sunday. All right, so let me know if you have any questions on that. I want to make sure, I think you're all seeing this, but every time that you turn in something on the course page, not that these, I'm going to make sure you are submitting these correctly, but last week when you turned in something for the practice exam, you'll see that I'm giving you a comment. So how do I get to the grade book? If I'm going to view this as a second, I'm going to switch my role to a student. All right, and there's a grades tab up here. So when you go to your grades, if you turn something in, there'll be a feedback, and you can look at that feedback. All right, so use the gradebook. Make sure you also should be getting an email notification saying, so when I get something, it comes into my email. So you should also be getting that. I want to make sure that you can access the e-text. So even in next week, let's go to next week. Because I'm a student, I can't see it anymore. Let me go back to my role, return to my normal role so I can see everything here. Next week, just make sure when you click on this, I'm not always putting you into the textbook where you need it, but you'll see that hopefully you're getting into the textbook. If you're not, please tell me. On the making sure, the one other thing was making sure we're doing these lessons correctly. I have one open. I just want to show you what happens here. So when you type in answers, I get these emailed as long as you do the last page correctly. So I just want to make sure that you're doing the last page correctly. All right, finish. Right, it's saved. Next. I got to get to the end. I'm just skipping. I'm not earning any points. You can see I just am trying to get to the last page of this lesson. So this one is just showing you all the things you're going to learn in this unit. Just trying to jog your memory about what you know. All right, on the last lesson, do I have any questions? I do not have any questions. And notice my always misspelling. Finish. All right, this is the most important part. Down here, it needs to be your name. So my name is Emily, so I'm going to put my name. I don't need to type in an email. It's programmed to go to my email. I need to click email score. All right, and then I need to click go back, and I need to click finish. All right, so the email part sends me, see, there's that introduction lesson. And do you see I get to see who sent it to me because it's going to tell me your name. And I'm going to see how long you had it open, the points you got, the essays you answered. This really helps me follow your learning. So please make sure that you're submitting those on the last page like that. All right, that is all of our little housekeeping stuff. All right, so let's go through these two questions that lots of people have. This question is difficult for most. All right, so I just wanted to go over my thinking on this. You can see I kind of color-coded this. My thinking was to start with the graphs, and I kind of thought, okay, I started thinking, which ones are linear? That's the L. So I looked up here, and I'm like, okay, these things are linear, right? Because the change in X and the change in Y is always consistent. So I went through, and I found the linear ones first. That's the L's. All right, and then I started looking, okay, there's some x squareds. This would be an x squared if I multiplied out. This would be an x squared. This is an x squared. This is an x squared. These are all going to be something squared. These are all going to look like parabolas. So parabola, 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 parabola. All right, which one has it? The upside down parabola has to have a negative x, right? So I just started going through, and then I looked to see over here what works like that, right? Oh, this looks, I saw 1 and 39. I'm like, oh, that works really well. And then I checked the rest of it. All right, so the one thing that many students mess up on is that choice A is graph F. So you have to be really careful. You can't pick F over here when it's graph F is A. So the choice for graph F is A. All right, so you just have to be really careful with that slide. I know it's a tricky one. The other thing that a lot of students had difficulty with this week, I get a lot of questions on the greatest integer function. All right, we have to remember that the word integer means a whole number, positive or negative, but it's a whole number, 1, 2, 3, -1, -2, right? It's always coming out as a whole number. So that means that the greatest integer of 2 is still 2, right? But it says the greatest integer less than or equal to x, right? So 2.3, that's a decimal. It's going to go down to 2. Doesn't matter how close it is to 2, it always goes back down to that integer. So 1.99 goes to 1, 0.002 goes to 0, -3.5. These are where it's tricky because this is a negative number. So it's going to go to -4, right? You have to see that this is past -3, so the greatest integer for it is -4. All right, and then this shows a table of values of what's happening and the graph, right? No matter anything between 1 and 2, right, is 1, right? Anything that I pick in for x between 2 and 3 is an output value of 2. And so the graph looks like this, where this, when it's 1, it's going to 1, not 0, right? And so we have a problem here. It says a global data plan costs $25 a month for the first 100 megabytes and 20 for each additional megabytes. Draw a graph of C in dollars. Well, from anything from 0 to 100 megabytes, it's just going to be 25. And then from anything to 100 megabytes to 200 megabytes, it's going to be 25 plus 20. So let's look at what that looks like, right? First is going to be 25 when x is 0 to 100. Right? That's showing it here is going to be 25. Then between 100 and 200, well, now it's going to be 25 plus 20. And it's going to be that the whole way till I get to 200. And then it's going to jump because now I have to pay 2 times 20 plus the original 25 and so forth. All right, so I hope that helps with those two common questions. And if you have more questions about it, let me know. All right, the next thing I want to do is going to be so important for us is to review key terms. And this is where you're going to start to do stuff for this lesson. So you're going to need to pause the videos and see if you can fill it in and try to use one color, right? Maybe a pencil or a blue pen, or I don't know, whatever you have. That's one color to fill in what you know, and then fill in another color for something that you don't know. All right, so here we have, right, 3 little boxes of key terms. This one's not fitting here very well, so let's fit this one over here better. All right, now they fit better. All right, so a function is a mathematical relationship that maps a set of blank. All right, so pause the video. Can you fill in these blanks, right? Can you just think, what terms might I put there? All right, and this is just telling you, so this might just be I take notes, right? It's increasing if, right, and decreasing function if. All right, so after you pause this video, I'm going to kind of go over these terms after you've written down what you know. All right, so now we're going over what we know, right? So remember that a function is a set of input values, right? So did you put that to a set of input values to a set of output values, right? Where each input value is mapped to exactly one output value. That was back to my joke, right? Each input value goes to exactly one output value, not each input value goes to a copy or a duplicate of an output value. Right? That's what makes it a function. The input values, we also call these the domain, right? Also, the set of all input values are the domain, and we usually use an X for this and call it an independent variable. The output values are the range, right? That's all the output values together are the range, and we call this the dependent variable because what happens to Y, right, is dependent on X. All right, we use this function notation. We can give it a name, usually F, G, H, C, doesn't matter. We use a letter. So this is the name of f of x. Notice how I read it, f of x. This is always showing me my input value, and this is always going to be my output, what happens. So when I put x in, right, what happens? So here, f of 2, right, 3 times 2 plus 1 is 7. F of negative 4 would be 3 times negative 4 plus 1 is 11. So input is 2, output is 7. Input is negative 4, output is 11. And you should have done that in algebra too. All right, just to kind of make sure you got these, a function is increasing as the input values increase, the output values always increase, right? So here we're increasing, we're going from this x to this x, and our f of a and our f of b, right? So this is the a, and this is the b value. This is going up, right? So that is what makes it an increasing function. Now, if I want to say this analytically using notation, if this little value down here is a, and this is b, a is less than b, which means f of a is less than f of b, right? This value is smaller than this value, and on the function, this value is smaller than that value. And here's what it looks like graphically, right? It's increasing function, all right? It's decreasing. Well, we're just doing the opposite of that, right? As the input values increase, right, I'm getting bigger x values, the output values decrease. The graph is going down. It's kind of, so as a is less than b, f of a is greater, right? This value over here is bigger than this value over here. All right, so let's try a different one. Same idea. You put in what you know. So we have these we have a generic graph here. You can just sketch that, right? Color the zeros. Where are the zeros of this graph, right? The graph intersects the x-axis when the what value, right? And then where's the y-intercept? And how can I label concavity up, concavity down? Straight lines don't have concavity. And show on this little graph here, where is the point of inflection? Do you remember where that concavity changes? Then after you're done, pause the video, and then I'll explain it, and you can add to what you sketched. So here we have, these are our zeros. Hopefully you labeled those, right? 0, 0, 0, where the graph touches the x-axis. So what happens here? The output values, the y values, are 0. That's why we call them zeros, because the output values are zeros. We call the input values the zeros. So the actual x's are the zeros. So if I wanted to say what these are, let's say x is -2, maybe x is 4, and x is 6, right? These are just made up because we don't know the values. But when we ask for the zeros, we're asking for x values. The graph intersects the y-axis dependent. That is the y-intercept right up here. This is the y-intercept, right? Because the input value is 0, x is 0, and the y value is the y-intercept. All right, so concave up is a bowl that's opening up, right? I look at this as the smiley face of the graph and a bowl facing down, all right? So here we have the slope on a concave up graph. The slope is going to be increasing. On a concave down graph, the slope is going to be decreasing. Straight lines have no concavity, and the point of inflection is right here is where it changes. So something is going from concave down to switching to concave up. We call that the point of inflection. So hopefully you know the zeros, the y-intercept, right? How do we know a graph is concave up? And how do we know a graph is concave down? So let's try to answer a question. So we're going to try to label this. So you want to sketch this out, right? And it says use the graph F. So this whole graph is called F, right? How can I label? You could use the letters or notation to label a graph concave up, concave down, the zeros, the y-intercept. When is the graph increasing and when is the graph decreasing? So go ahead and give that a try, and then I'll give you the answer. So pause it, and then when you're ready, hit restart. All right, so there's a couple ways we can note this, right? We can use greater than or less than signs, or we can use brackets, and this little u is union. So when is the graph concave up? Well, the graph is concave up here, and then here again, right? So we have concave up, we have concave down, we have concave up. That's the red and the green and the red. So the question is, how do I label this? Well, x is less than I. So from here over, the graph is concave up. So I could label it x is less than I. And how do I label this part? Well, x is x is greater than k, going this way. X is greater than k. So this would be a right answer. Or this is saying from negative infinity up to I, and the union is an and from k up to infinity. Both of these are saying the exact same thing. All right, when is the graph concave down? Well, from I to k. So how do we say that mathematically? X is greater than I, or I is less than x, and x is less than k, right? It's in the middle. Or I can use these brackets, bracket I to k. Why are these brackets rounded? Because we're not including the exact value at I. If they were square, we would be including those values, right? All right, 0, well, x equals g, and x equals m are the zeros. Y-intercept, y equals a, because it says f of 0 is a, just generically some value a, so y equals a. The graph is increasing. The graph is increasing from here to here, right? What's going up, sorry, to j. And the graph is again increasing from here to here. So how do I say that? Well, again, x is between h and j is one way, and x is greater than L, right, going this way. Or I can use between, this is another way of saying between h and j, and from L to infinity. All right, decreasing, the graph is decreasing here or from to here, this section, right? And again, x is less than h because it's going this way, right? It's decreasing over here. So from all the way, right? Decreasing all the way here. I can also say that from negative infinity to h. And then I want to say between j and l. So x is between j and l, or right, j to l, and use the brackets. So both of those are ways in which you can label the graph in an acceptable notation. All right, next one. Just let's practice defining in situations what is dependent and what is independent. DEP stands for dependent, and independent is here. So if I have b of s is a function where b is the number of books in the library and s is the number of students in school, right? The dependent variable is the number of books, and the the independent variable is the number of books, and the dependent variable is, function is b is the number of books in the backwards. S is our independent variable, right? We're picking, so S is the students and dependent is the number of books. All right, you try the second two and then pause it and then pick it up to see if you catch them. All right, so now we have P of t is a function where t is the number of years since kindergarten and p is the number of Pokemon cards. How many Pokemon cards you have is dependent on the number of years since kindergarten. And c of t is a function where c is the number of cups of coffee consumed and t is the number of teachers in the school, right? Dependent is the number of cups of coffee and independent is the number of teachers. All right, so make sure you got independent and dependent. We're moving right through this lesson. It's not too much longer. We're going to do a couple College Board practice questions and you'll be done for this week. So it says we have two questions here. We have questions 17 and 18. I'm going to do 17 first and then I'll pull 18 up. So it says the figure shows a graph of a function f. Let a, b, c, d, and e represent the x coordinates of the points on the following. Which is the point of inflection? All right, so is it A, B, C, D, or E? I hope you remember that C is where it changes in concavity. That's point of inflection, so that's 17. And 18 says same thing. Let represent coordinates of these, which is on which interval is f decreasing? This is two parts. Is f decreasing and the graph concave down? So we have a section here that's decreasing, but this is concave up. So we have a section over here that's concave down, right? And so which one is decreasing? Pause, see if you get it, and then I'll give you the answer. All right, so C I gave you right away, and hopefully you got D to E right, because here is concave down and decreasing. All right, two more questions. I really wish, nope. I was trying to fit this better. There we go, fits better. All right, so water is poured into an empty vase at a constant rate. Here's our vases. A graph, which is not shown, models the depth of the water in the vase over time. So we have time. On the y-axis, we have depth. So we have how much water is in that vase. The graph can be described as follows. The graph is always increasing. The first portion of the graph is clearly concave up. The next portion of the graph has a fairly steady and steep increase. Which of the following vases is appropriate for the context described of the graph? All right, so pause it and see what you get. When you're ready, restart. All right, I hope that you got B, because it says the graph is always increasing, right? Both of these graphs are going to have C and D are going to have a place where they're not always increasing. And this one too, because it's going to be coming in and the depth's going to go faster up to a certain point, and now it's going to go slower, right? It's not going to go as fast as time, so it's not going to be as steady. And this one is going to be it's going to be very consistent where it's all the same depth. It's going to go very slow, so it's going to look almost like a straight line. Same thing, this is going to have almost a straight line here where it's filling very slowly. And because this graph has this shape where it's always increasing, right? And it's going to go really, really fast after it gets up here to the top. All right. All right, last question, and I want to help you. If you clicked, if you were on the College Board and you saw this little calculator, Desmos will pop up. So I'm going to show you how to use Desmos to solve this question. All right, a ball is thrown through an open window to the ground below. The height of the ball in meters at time t seconds after it is thrown can be modeled by this function. H of t equals negative 4.9 t squared plus 4.4 t plus 15.24. Hopefully in Algebra 2 you have dealt with some quadratics and you know that this quadratic is upside down, right? All right, so see if you can use Desmos or your calculator to solve. And when you're ready, let's restart and I'll show you how to use it if you don't know. All right, so here we're going to restart, and I already put this function into Desmos. All right, now, so I have the function in Desmos, and I don't see the whole parabola. So how can I deal with that? I want to go up to this little wrench, all right, and I have all of my x values, so I don't really need to change this. I don't go high enough up on y, so I'm going to try to go up. And I know my y-intercept is 15.24 because if I put 0 in for x, I'm going to have 0 and 0. So let's go up to, say, 20, and then I can catch the top. All right, and I can also click on this to see when x is 4.45 roughly, y is 16. That's the maximum of my graph. All right, so now let's take, I'm just going to take a screenshot of the graph here. So, and I could also put in the zeros here. Let's take that one. All right, so now when we come back over here to Keynote, let's try to see our answer choices with, get this stuff all out of our way with that graph. All right, so now we got these answer choices. So the ball begins at the maximum height of 15.24. Well, it's beginning here because time, like we understand that we can't have negative time. So time has to go from here over, but that's not the maximum height. So it can't be choice A. Right away we can stop. All right, because it says the ball begins here and it decreases. That's not true. It increases for a while. The ball begins at a maximum height. The height of the ball decreases until it reaches the ground. Well, no, it's still not a maximum height. After leaving the window, the height of the ball increases to a maximum height. Then the height of the ball decreases until it reaches the ground 1.82 seconds after reaching its maximum height. All right, so let's see here. We have from, let's read the second choice to see which one makes more sense. So, because this say the same, after leaving the window, the height increases to a maximum height. The height of the ball decreases until it reaches the ground 2.269. Now, you might be really tempted, right, until it reaches the ground after reaching its maximum height. 2.269 after. We see 2.269 here, but that's not after it reaches its maximum height. 2.26 is from 0. So from here to here, if I say 2.269 minus 0.44, I'm going to get 1.8, right? Because it's after it reaches its maximum height. So the answer choice has to be C. All right, you did very well sticking with this lesson. These are a little bit long, but there are lots of practice for you on Friday of what you've gone over during the week. What I want you to do on the course page where you see video lesson 2, all right, you're going to upload any notes you took, and you're going to upload evidence for me that you did the practice I just went through with you. And if you have any extra questions, just put it in when you load that so that I can see that you still have problems with stuff. All right, and you'll notice every week I add a little extra practice for the week. All right, so the video won't necessarily play in here. I found a really great teacher who does extra work, so I'm always putting these in here if you find that you still need extra practice for the week. You don't have to do these. These are completely optional. So thank you for your attention in this video lesson, and let me know if there's anything that I can help you with.